Okay, so now we are going to talk about predicting products, but specifically for when we talk about decomposition reactions. So again, we're going to use the reaction template to figure out the type of reaction, the reaction template to figure out what the products are going to be. We're going to check the charges of the metals and nonmetals and crisscross them down. If it's a single replacement reaction, we'll use the activity series of metals. If it's a double replacement reaction, we'll use the solubility rules, and then we'll finally balance the equation. So this is a decomposition reaction. And as a result of this being a decomposition reaction, I know that the reaction template is going to be AX, or compound AX reacts to produce A and X. So in this case, what we're really doing is we're just separating the elements that are present. So I'm going to simply take the elements and match them up on the product side of the template, and I'm going to write aluminum and I'm going to write nitrogen. Now, before we get into balancing this, which would be something that'd be easy to do, we have to remember that there are certain elements that when they are by themselves, they get a 2 after them because they're diatomic. And those elements would be Br2, I2, N2, Cl2, H2, O2, and F2. Those are your diatomic elements. If I look at this list and I see that aluminum is not part of the list, then aluminum stays as it is. If I look at this list and I see nitrogen as part of that list, then nitrogen gets a 2. So now I can go back and balance my reaction. So I have aluminum on both sides, and I have nitrogen on both sides. On the left side, I have 1 aluminum, 1 nitrogen. On the right side, I have 1 aluminum and 2 nitrogens. So in order for me to balance my aluminum or my nitrogens, I'm going to put a coefficient of 2 here, which will give me 2 aluminums and 2 nitrogens. So my nitrogens are balanced, my aluminums are not. So I'm going to add a coefficient of 2 here, which will give me 2 on both sides. So that was example problem number 1. We're now going to go ahead and do example problem number 2. Here we have Fe2S. And again, our reaction template for decomposition reaction is AX reacts and separates into A and X. And so we're just going to go and match up what we have. So in this case, Fe is under the A on the left side, and it's going to be under the A on the right side. S is under the X on the right side, or on the left side, and so it's going to also be under the X on the right side. And now, before we go any further, we should check to see if either of these elements need a 2. So we're going to check this list: Br2, I2, N2, Cl2, H2, O2, F2. Fe, iron, not in the list, so we're not going to add a 2 to it. S, sulfur, not on the list, so we're not going to add a 2 to that either. So when we go to balance this equation, we have Fe on both sides and S on both sides. On the left side, we have 2 Fe's and 3 S's. On the right side, we have 1 of each. In order for us to get 2 Fe's, I'm going to put a coefficient of 2 here. In order for us to get 3 S's, I'm going to put a coefficient of 3 there. And then that one, both of these are balanced. So that wraps up how we do decomposition reactions. And if you have any questions, make sure that you consult your the note sheet and you take a look back at the notes you've taken here. And other than that, we will go over this going forward.